let's have example 1. So we're asked to find or simplify the following using sum or difference. Okay, so let's start with example number 1. So we have sine of 3 pi over 2 plus x. Okay, so since this is sine, so we're going to use sin, cos, cosine pattern. Okay, so we will have sine of 3 pi over 2 cos of x. So our second angle is x, so this is A and this is B. Then since it's sine, okay, so sine, we have same signs, so plus cos of 3 pi over 2 sine of x equals sine of 3 pi is, so since it's 3 pi over 2, sorry, see that 3 pi over 2, so it's actually 270 degrees in degrees. 3 pi is 270 degrees, so it's actually negative 1. So we have negative 1. So we have negative 1 times cos x plus, so cos 3 pi over 2, since 3 pi over 2 is in the y-axis and cosine always refers to the x-axis, this is 0. Okay, so 0 sine x, and this will give us negative cos x. So this is our answer. Let's have example 2. So for example 2, we have sine of beta minus alpha over sine alpha sine beta. So obviously we are going to use sin cos cosine because the angle or the angle of sine here, the numerator is beta minus alpha, or has two terms. Okay, so it's sine again, so it's sin cos cosine. Sin cos cosine. So we'll have, so our beta is A, our alpha is B, this is A and this is B. So we'll have sine of beta, okay, cos of alpha. Then the operation is minus, so it's minus here. Minus cos of beta, the first angle is beta, then the second angle is alpha, sine alpha. All over, so sine alpha, just copy alpha sine beta, so never mind. Okay, so let's try to simplify further. So if we have a binomial over a monomial, so take note, this is a binomial over a monomial. Okay, this is binomial over a monomial because we have the minus sign here, so we can actually separate. Okay, so we have sine beta cos alpha all over sine alpha sine beta minus cos, so we have the second term, cos beta sine alpha all over sine alpha sine beta. So we did copy the denominator of the terms. Okay, and try to observe, we can actually cancel out things here. So canceling, we can cancel out sine beta in the first term, and we can actually cancel out sine alpha in the second term, and voila, it's now obvious. I hope it's obvious. So we have cosine over sine. Take note, cosine over sine. So in our quotient identity, cos theta over sine theta is cotangent theta. Okay, so we will have cot, so our theta here is alpha, so cot alpha minus cosine over sine beta, so we have cot beta, and this is our answer. So we have simplified this to this. Let's have example number 3. So for example number 3, we have cos 30 degrees minus x plus cos 30 degrees plus x. So we have two cosines here. So remember that cosine, if we have cosine, starts with cosine. So it's cos, cos, sin, sin. Okay, so let's use this one. So we have the cos of the first angle. So we have cos 30 degrees. Cos, so I'm doing this first. Cos of x. And if it's minus, so it's cosine, then minus. Always remember that if it's cosine, it's the reverse. Okay, reverse of the sign, reverse of the operation. If it's minus, it's plus. We have plus cos, sin, sin. So sine 30 degrees, sine x. Okay, then let's try the next part. So for the next part, we have cos 30 degrees plus x. So we have cos, sin, sin again. So cos 30 degrees, cos of x, then it's plus, so it's minus here. So minus sine, sorry, it's sine. It's sine of 30 degrees, and then we have sine of x. Okay, and we can now simplify. So we have cos 30 degrees. So in your calculators, take note, it should be in degree mode because our given is 30 degrees. There's another shortcut here. If you're very familiar now, familiar with the unit circle, we have special angles. Okay, so for special angles, we have special values. Always remember that cos is x and sine is y. Okay, so here we have, if it's 0 degrees, so we know that our cos is 1, our sine is 0. Okay, then if we have 30 degrees, so for 30 degrees we have cos is square root of 3 over 2, y is 1/2 for 30 degrees. Okay, then for 45 degrees, okay, 45 degrees, we have square root of 2 over 2, square root of 2 over 2. Okay, then for 60, so 60 and 30, they are actually multiples, so they have a relationship, so it will be the reverse. So instead of having square root of 3 over 2 and 1, so for 60 we have 1/2 square root of 3 over 2. Okay, then we have 90 degrees. For 90 degrees, it becomes 1, 0. So it's 0, 1. Okay, it's 0, 1. Okay, 0, 1. Okay, so we have 1, 0, square root of 3 over 2 and 1/2, square root of 2 over 2, square root of 2 over 2, then we have 1/2 square root of 3 over 2, and we have 0, 1. So these are special angles. So if you don't have a calculator, you may use this idea. But if you have your calculator, so simply use your calculator, put sine or cosine. So let's try. So we have cosine of 30 degrees. So if it's 30 degrees here, the cosine is x. So our x is square root of 3 over 2. So we have square root of 3 over 2. Cos of x plus sine of 30 degrees, sine is y. So y is 1/2. So 1/2 sine of x. Plus, so we have cos 30 degrees again. So this is square root of 3 over 2 cos x minus sine of 30 degrees, which is 1/2 sine x. Okay, let's see if we can simplify Oh, so we can simplify something here. So rearranging our terms, I'll rearrange. So we have square root of 3 over 2 plus square root of 3 over 2. We will have 2 square root of 3 over 2 cos x. Then we have 1/2 minus 1/2 sine x. So it's 0. Okay, so it's 0. So plus 0. This will give us further. So cancel 2 over 2. So last final answer would be square root of 3 cos x. And this will be the final answer. So from this, we have now this square root of 3 cos x. Okay, so example number 4, we have tangent. So it's tangent of 5x minus tangent of 4x over 1 plus tan 5x tangent 4x. Okay, so here, it's very obvious that we're already given here a clue. So remember that for tangent, the tangent of a plus or minus b, we have tan a plus minus tangent of b over 1 minus plus tangent of a tangent of b. Okay, so whatever is the sign. So if it's minus, so we'll use the minus, then minus plus pair. Okay, so here to simplify, we're going to reverse the process. Okay, so first identify the angle, the first angle. So obviously the first angle here is angle A. So angle A here is actually 5x. And we have angle B, which is 4x. Okay, so let's try to answer. So if we try to reverse, this becomes tangent of 5x. It's minus here, so it's minus the second angle, which is 4x. Okay, then if we try to simplify further, this becomes tangent of x. And this is the final answer. Let's have example number 5. Okay, so for example number 5, we have 3 terms here that contains the sum and difference. Okay, so we have sine. So again, it's sin cos cosine. So I don't do, I just write it. Sin cos cos. Okay. So let's try to use the identity. We have sine of A cos of B. Since it's minus, so we'll use minus here. Cos of A, cos cosine sin. So cos cosine, sin cos cosine. Okay, sine B. All over, we have cos A, cos B. That's it. Okay, next, we'll have sine B minus C. Let's change color. Okay, so we have sine cosine cos cosine. So sine B, sine cos cosine, cos C minus cos B sine C. Yeah, sin cos cosine. Okay. All over cos B cos C. Okay, then let's try to change color again. Let's have blue. So plus, we have C minus A. So we have sine C cos B cos C sine A. All over cos C cos A. So we just copy the denominator. Okay, so in the red part, we're going to separate. Okay, let's separate everything. So we have sine of A cos B. Denominator is cos A cos B. Since our operation is minus, so we'll have minus cos A sine B all over cos A cos B. Okay, then let's have the other one. Let's have the green one. So plus sine B cos C all over cos B cos C minus cos B sine C all over cos B cos C. Okay, then let's have the blue one. Okay, blue one, you plus sine C cos A all over cos C cos A minus cos C sine A all over cos C cos A. Okay, so it's cancellation time. Okay, cancel it. Let's cancel. What can we cancel here? In the first term, we have cos B. Okay, how about here? We have cos A, second term. Third term, we have cos C. Fourth term, we have cos B. And fifth term, we have cos A. And the sixth term, we have cos C. Okay, so let's rewrite. So we'll have sine A over cos A. This is simply tangent A. Okay, then here we have sine B, so minus. Sine B over cos B is also tangent, but it's B. Okay, then we have green. Sine B over cos B is tangent B. Minus sine C over cos C is tangent C. And then we have blue for the blue. We have plus sine C over cos C. We have tangent C. And then we have sine A over cos A. We have minus tangent A. Okay, let's see if we can simplify further. So we have negative tan B and positive tan B. So we have 0 here. Tan A, so this is A. So tan A minus tan A here, tan A minus tan A here, so cancels 0 also. We have negative tan C plus tan C, so this is also 0. So finally the answer is 0. Okay, so the answer is 0. And that's the end for part 1. For part 2 of lesson 12, we'll be having the double angle identities. See you in the next video. Bye bye.